right now I'm going to show you how, using the Viam platform, I'm going to be able to very quickly start prototyping some automation on this arm. We're going to show how the power of the Viam platform lets me get started super fast, gives me visibility into what I'm building without my having to write a bunch of extra scaffolding. We're going to see how the platform's abstraction layer lets me very quickly incorporate this arm into the same process. So let's get started. The first thing I'm showing here is an empty machine. It has two components. It has a main part and a sub part, which we're going to use later. Right now we're just going to work on the main part. So the way we build machines in Viam is by representing its fundamental building blocks using components and services. Components represent the hardware, and I'm going to use this configuration block finder to find a configuration block for the robot on the right, which is the Universal Robots UR5e. And so let's do that, UR5e. And here it is. Okay, so we're going to get that hardware-wise. We have this System 76 Meerkat, and it's the Viam host. It's running Viam server on it, and it's connected to the main network of our laboratory here, and then here via the switch, it's connected over Ethernet to both of these arms, right? And so that's what we're representing here in this machine configuration. So I'm just going to grab the details from my notepad and paste them in here. Okay, here we have it. It's the host IP address and details about the speed and acceleration, degrees per second squared, that the arm is allowed to move. And when I save this, I just hit Command S, but that button up here, do that as well. We see that that little red chip over here that indicated that the arm was unhealthy has gone away, and indeed, when I pop open this little test card here, see it's ready to test, right? And without having to do a single other thing, I can already control this arm. Here, let's move the base joint a little. Hey, it's moving. Amazing, right? So I didn't have to write any scaffolding. I didn't have to write hello world. I literally said I need to use this arm, add it to a machine, and it's up and running. And we're going to do that with the other hardware. I have a depth sensing camera here, an Intel RealSense, same equipment as we have on this arm. The only difference between these arms in terms of like what they're capable of, this thing has a gripper. We didn't have a gripper in the lab that fits the UR5 right now. But that is also going to show off the flexibility of our system here. So let's add the camera. Just run through this. You've seen it before now. RealSense. Great. I'm actually going to add the discovery service. So it's both the camera model and the discovery service come with the RealSense module. And I'm going to say RealSense discovery, add that component. It is not yet deployed to the machine because I have to save the changes. Once I save them, that's when the host is going to notice that there's a new config to pull down, which incidentally it is caching. So if it falls off the network, or for some reason can't reach VM Cloud, it will still have its configuration, can still run. Okay, so the RealSense discovery service has been deployed, and we've got this handy little ready to test. And when I pop it open, so what we're seeing here is that this thing that we call a test card is flexible. For the arm, the test card shows me the ability to control the arm. For the discovery service, what it's showing me are the cameras that it's discovered. So we're going to start by adding this component here. We just press the button and the RealSense camera shows up here. I'm going to rename it. I'm going to call it just RealSense. Here we are. The RealSense camera is up and running. It's ready to test. Whee! So now I'm going to pause here and point out for a second that this UR5e is specified as, here's the name of the component, here's the type of the component, and here's the model itself and its registry path, right? It belongs to Viam, it's the Universal Robots module, and it's the UR5e model. The most important thing here is that this is an ARM API. Literally anything that is an ARM will have the same surfaces for Viam applications to touch. Same thing with this. Here's a RealSense camera. right? We have the module path and we have the API type, right? Here's the camera. And now I'm going to add another type of service. It's the vision. It's going to be a vision service. And the one that I'm going to use is a color detector. We'll add that. We're going to call it color detector, simply. Save that off. And you can do a really simple configuration here, but I want to show you that you can go from here also to the JSON config. This is failing because it needs to know what camera it's getting its feed from. This is a color detector, and it's a vision type service. And a vision type service takes in images or video streams and outputs classifications, bounding boxes. So let's get the proper configuration. We're going to specify the color, what camera we're getting it from. The segment size pixels is basically the minimum number of pixels that we're going to accept as a qualification for this. And then we've got tolerance for the hue and saturation cutoff. These are all just specifying what range of colors will qualify as detecting ultimately what we're trying to detect, which is red. And now let's see that our color detector is ready to test. And here is the moment. We're going to have a look at that on that screen. We're going to see a red cube goes down and a bounding box appears over the cube, letting us know that it's 100% confident that this is something red. And if we want, we can get the actual coordinates of this box in the real-world frame. What is the real-world frame? Well, let's start looking at what the robot thinks its surroundings are like. All right, let's come back to the arm, and we're going to add a frame. Right now, nothing exists in this world. We've got a 3D scene that we can look at, and it has nothing in it. So when we come back to configure, the first thing we want to do is give the arm a frame. And we're going to say for convenience that this arm is literally the basis of the world. It gets no translation. It is right there at the origin of the world, and it gets and its orientation is defined as simply thinking that the z-axis is up. And we'll save this, and as soon as that happens, we now are going to be able to see this arm appear in the 3D scene. This visualizer is very cool and very useful. Right now, you're seeing this kind of overlay. You can configure this, right? What are we going to see here? This arm models thing, we're showing both the defined colliders and the actual model, right? So let's leave the colliders on. This is what the motion service will use to not run into anything. So now I have a arm, I've got a camera, I've got something that detects colors, and I'm going to add a couple of other things to make this do something interesting. I'm going to flip over to the JSON version of the configurator, the builder, right? We have this convenient GUI, and then we also have JSON, and that's where I'm going to take what I had on my notepad and paste in and save the config for this robot at the next stage. And we have added some poses. These poses say what joint position the arm is at. And so I have 3 poses here: centered, where it is right now, and pose 1 and pose 2. If we go to pose 1 and use the test card, what I have is the ability to update the config to where it is right now, or go to. And when I click it, we're going to see the robot moves. So this is a static position. And these are extremely useful for simple places that an arm belongs, simple poses that an arm should adopt. All right, so we've seen how I add hardware to this machine and can drive it myself. What we haven't seen is how to add behavioral logic to it, a controller. But I think it's worth pausing to consider how long this took me. If we include some of the typing that I didn't do by pasting in, adding in these poses, we're really looking at about 10 minutes of work, I think. Make it, double it. It's still pretty quick. Now let's imagine that I spend a little time writing some logic. What's happened is I've added this thing called a controller. We see that also my tech demo module has been added because that's what powers this controller, right? You see that the tech demo is the origin of this model. This is a generic service. And there's a special generic service. You can have generic components and generic services. The generic service has my code, and I've also been able to configure it with the names of some poses. They happen to share very similar names, but I could change these. This is dynamic. I'm also specifying here a target label, what I care about, red. And I'm specifying the color detector vision service over here that the controller is going to rely on, and the camera that it's going to be looking through. And now that this is deployed, I just have to issue a command to this controller. I'm going to issue a command to it to start watching. It's a loop that I've written. It's a very simple loop. So the way we issue a command is by sending a JSON block, start watching true. Great, status is watching, and look, it's doing something because it saw a red cube, which I forgot to take off the table. If I take it off the table, see, it's gone through those 3 poses that we talked about. Now it's returning to center. And now it's watching for something red. And we can see this in the logs over here. I'll pull those up. Right, watching started, running pose cycle, detected red, etc. Right, now it's waiting. And as soon as it sees something red, it's going to do its little dance. Let's say this was probably another 20 minutes just to write that code to get the arm, enter a loop, ask the vision service whether it found something, and when it does, just execute, go to those poses, go to those poses, go to those poses. We're going to use the bounding box for it later. Let's fast forward in time and look at the machine as it is now. I added another pose called stow to put this thing away later. I added a new thing called a cube finder. This, as you can see, is a type of camera. Now, it's a special kind of camera. It's a camera that needs to get a bounding box finder, a vision service, in this case, the color detector that I defined earlier, and a camera also that it's going to be matching the point cloud from to the bounding box. And what it's going to do is it's going to crop down whenever so right now it's got no input whatsoever, right? There's no output. And that's because the color detector has found nothing red. Color detector sees nothing, right? But if I put something red in here and it finds it, well, that now has become the input to this vision service pipeline where this cube finder now actually does have a point cloud in space. I don't want to collide with that pedestal, so I'm adding, this is basically, this new JSON block simply adds one thing, it's this pedestal. Right? This pedestal is an obstacle. It's borrowing the gripper API because it doesn't use it. We just need to have something that has a geometry and something that has a frame. And we can see it in the visualizer now. Here we are. Here's the pedestal. Now, if you kind of actually look at this, you can see that it's not right. The pedestal, the arm is centered in the pedestal. But I can correct that super easily by clicking on the pedestal and using this adjustment to walk it back. So let's try 10. Nope, 100. 10. Hey, that looks pretty close. How about 20? 120 millimeters, done. Right here in the visualizer. There are obviously more precise ways to get this done, but see how incredibly See how incredibly fast that was for me to get that obstacle done. And now, with obstacles defined, we can stop using simple joint positions and rely on the Viam motion service to plan an arm's path from where it is to a target location. That's been implemented here in this controller. And the controller now knows that it wants to get the cube finder, and we're using the built-in motion service. And I've also added a padding because this thing does not have a gripper. So, so I've added a number of millimeters. Now that I've suddenly started it watching, and it wants to pick it up. I mean, it can't. It doesn't have a gripper, but it wants to pick up the cube, and wherever I put it, and it sees it, it's going to go and try and pick it up. Pretty amazing. This is about a day's worth of work. The configuration of the hardware and the services was dead simple, and then the code for finding this cube and then moving to its position is very simple as well. Okay, so big moment here. We have done this all on this arm, but it has no gripper, and we really do want to pick up this cube. So the very first thing, first, let's just get it out of the way. We're going to stow the arm. Bye. Get out the way. Okay, and now let me paste in new config. Let's go back to the builder and see what I've done over here. We've got a new arm set up over here. It's the UFactory 850. That's that arm. It's got a gripper. It's also got a RealSense. The only difference is it has a different serial number. We're also using the color finder. We're also using the color detector. The pedestal, that is also here. And we also have some poses for the arm. We only need stowed and centered right now because we've already moved past these hard-coded positions. And the controller. Controller's the only difference in this entire rig is that I have configured it with different hardware, this arm and this gripper, and a different serial number for this RealSense. And we've just changed the config field over here. Nothing else has changed at all. When we save this, it's shutting down the UR5. It's done with that. It's reconfiguring everything. It's got the new UF850 module. It's ready to test. Same interface. Moves. Behold. Let's move it to the centered position. All right. Okay, so with all the pieces in place, go get it. Well done, well done. So, in perhaps a day's worth of work, we have put together a credible beginning to a pick-and-place machine that is hardware agnostic, where you could swap in different arms, different camera models, and it doesn't matter because they conform to the Viam APIs, and the code does not care what kind of hardware is underneath. It doesn't have to change. It's just a matter of configuration. Where we go from here, up to you.